Electrical system consists of 7 components as illustrated, and that's a picture. Um, the system functions if in each parallel subsystem at least one component works, and in each series subsystem all components work. Assume that the functioning or failure of any subset of components is independent of one another. What is the probability that the system is functioning? Show your work. So in this case, I see that the event that the system is functioning, W, or working, is equal to F intersect G intersect the union, as we T union, O union, I union S intersect L. So basically, the system functioning is when F functions and G functions, and one of T or O or I or S at least function, and L functions. So to compute this, we can assume that all of these are independent of each other. But I still have to compute this union, probability of this union. So let's try to find that probability. Probability of T union, O union, I union S. I know that I prefer intersections because then I can use the independence. So let's see if I can basically convert this to an intersection. And that is 1 minus P of T union, O union, I union, S complement. So 1 minus the probability of the complement is the probability of itself. And then I use the Morgan law to get P of T prime intersect O prime intersect I prime intersect S prime, which then I can use the independence of events and to write it as P of T prime, P of O prime, P of I prime, P of S prime. And so what is that? That's minus 0.3 to power 4. Now, to be able to compute the probability of the system working, all I need to do is multiply this value by probability of F and probability of G times 1 minus 0.3 to power 4 times probability of F. And what would that be? That is probability of F is 0.8 times 0.9 for probability of G times 1 minus 0.3 to power 4 times 0.8 for probability of L.